Okay, welcome to lecture number 17. In earlier lectures we have seen good amount of geometry. In this particular lecture we will practice little bit of algebra, and this algebra will be useful eventually to find out properties about geometry only, few properties in geometry only. Now if you go through the classwork, you will find first two questions which are absolutely simple, and students of this age typically in 8th standard, they are very poor in handling Sir's equations involving radical sign, square root sign, and therefore couple of examples are given and you are supposed to find out which statements are true, which statements are false, and then in second example some wrong calculations are done which you are supposed to figure out what is wrong in that particular calculations. So they are simple ones. If you are in question about what is the correct answer in first, what is the wrong in second, you might as well have to go through your basics and get those things corrected. Now let us look at problem number 3. In problem number 3 also there is some mistake which is being deliberately performed, and it is expected that we find out what that mistake is and report, because the algebra which is being done in question number 3 is not correct, right? So I will not disclose those answers as they are very easy, and we will get into proving 5 identities which are given in question number 4 of lecture 17. So let us directly go to problem number 1. Problem number 1 says s into s minus b plus s minus 8 into s minus c. If you expand this, you will get a into c. That is what is the requirement. We are supposed to prove it. Now I request you to pause the video at this stage, try your level best to simplify. Now here s is semiperimeter, which is not mentioned actually in the problem, but the notations are such that we understand s is semiperimeter, which is a plus b plus c. So s is equal to a plus b plus c upon 2. So if we take s is equal to this and ABC are essentially sides of triangle ABC, then I would request you pause this video, try yourself to solve this. If you don't, again start and then look at the solution. Now let me solve. LHS, I simply expand s square minus sb plus s square minus sc minus sa plus ac, that is LHS, which is 2s square. Then I can take out minus s common from these three terms, which is minus s times a plus b plus c, and plus ac remains as it is, okay, which is 2s square minus s. Now a plus b plus c is 2s plus ac, which is 2s square minus 2s square plus ac is equal to ac, which is RHS. So it is as simple as that. You just expand those brackets and you will get the answer. Okay. Now next question, and you will find that all the remaining questions are also similar. So let us solve first two, and I will leave it to you to solve the remaining. Okay. Now when we want to find out about distance AI, we need to consider the diagram which we have already learned earlier. This is in center I, We drop perpendiculars from I onto the sides. Those are D, E and F. This is A, B, C. And then distance AI, prove that distance AI is equal to radical S minus A into BC divided by S. That is what is the requirement. Okay. Now, with respect to this diagram, we are supposed to prove this. And of course, for proving this, we will take help of the identity that we have proved earlier. Okay. So now again, you have to spend a lot of time in trying this out yourself. And if you don't get, then listen to this video, watch this video. Now, instead of writing this, we know that this is 90 degree here, and we consider triangle AFI, okay, in which we are supposed to find out AI, and we know IF is small r in radius, and AF is S minus A. Distance AF is S minus A. Therefore, first simplification which I will immediately do is AI square, which is equal to S minus A into BC upon S. This is what I am interested in proving. Okay. So consider triangle AFI, which is right angle triangle. Therefore, applying Pythagoras theorem, we get AI square is equal to S minus A bracket square plus R square. Okay. Now we already know that delta is equal to, or delta square is equal to S into S minus A into S minus B into S minus C, and delta is equal to R into S. This implies R is equal to delta upon S. Correct? And now therefore R square will be equal to delta square, that is S into S minus A into S minus B into S minus C upon S. So R square will be equal to S minus A into R square will be, this will be square here. So S minus A into S minus B into S minus C upon S. That will be our R square. So we write down that identity here. We get S minus A bracket square plus S minus A into S minus B into S minus C upon S. Okay, replacing this R over here. Now LCM if we do, then it is S times S minus A bracket square plus S minus A into S minus B into S minus C whole divided by S, which is equal to, now I can take out S minus A common, which we require here. So S minus A common. What will remain inside bracket? S into S minus A, S into one of the S minus A's, minus S minus B, plus S minus B into S minus C upon S. Now you will observe that this bracket, this second bracket is nothing but BC, which is equal to B into, so first bracket is S minus A, second bracket is BC upon S, which is equal to what we are required to prove. Right? So we have found out AI square using the first problem, and in first problem actually we have proved AC, but there S into S minus B was there together, and S minus C and S minus A were getting multiplied, hence AC was the product. Here S minus B and S minus C are getting multiplied. So by symmetry we will get BC here, and we will end up proving this result. So this is result number 2 in problem number 4. of lecture 7. Now similar work is required to be done for AI1 square. Let us check whether we can do it or not. Okay. I hope you have got this proof properly. It is also recorded properly. So if you want to copy or if you want to study it in detail, maybe you can pause the video, maybe you can rewind the video, check it again, check the calculations on the board, copy them down and learn it properly. Okay. Now the third problem, I will erase this. Let us do third problem. Third problem requires AI1. Therefore, we will draw diagram where we have, suppose this is triangle ABC, and then the internal angle bisector and external angle bisector. They intersect at I1. We draw perpendicular. Then this is foot of perpendicular on AB, which is F1. So here we are going to consider triangle AI1 F1. So again, AI1 square is equal to S into BC upon S minus A. That is what we are supposed to prove. So we will again start with Pythagoras theorem. Triangle AI1 F1 by Pythagoras theorem, we get AI1 square is equal to AF1 square plus I1 F1 is R1 square. Now, what is AF1? AF1 we know that it is semiperimeter S square. And what will be R1? R1 will be delta square upon S minus A square. Delta square upon S minus A square. So what is delta square? So S square plus delta square is S into S minus A into S minus B into S minus C divided by S minus A bracket square. If we simplify, one S minus A gets cancelled. LCM of this entire term, 1 S minus A will come here. S minus A inside bracket S square plus S into S minus B into S minus C whole divided by S minus A. This will be the simplification of this. And now we can take out something common, which is S common from the numerator. So S upon S minus A, which is what we require, and the remaining bracket if we write, it will be S into S minus A. S from here one taken out, S minus A continues to remain, second S continues to remain, plus S minus B into S minus C. This is my second bracket, and again you will observe the second bracket is equal to B into C. Therefore S into BC upon S minus A. This is what we wanted to do. So this is all about finding out how much is AI1. I am sure after I have shown you how to find out AI1, you will be able to do AI2 and AI3 independently. Now by cyclic symmetry, all remaining expressions, that is BI, BI1, BI2, BI3, CI, CI1, CI2, CI3, all of them you should be able to do. Now, this is what is everything about lecture number 70. Right? Now, as far as lecture number 18 is concerned, you will observe that it says that you are supposed to discuss the homework problems, and then there are 10 more problems in lecture 18. Lecture 19 also homework problem and 10 more problems in lecture 19. So we will see what we can do best in those particular lectures. Thank you.